So now we have Karamba calculated model that we can send it to Revit. To send it, Karamba model to Revit, we need to install Geometry Gym by John Massin. We need to go homepage Geometry Gym, and on the download, you can download Bull and for Rhino and Grasshopper, and also you need to download Revit installers, which you can send as IFC data here. You need to install them. Once you install them, on the Grasshopper in Geometry Gym plugin, you can see all the components that we can send Grasshopper data to to Revit. Okay. For now, I'll hide this model view, and also I'll hide these model lines. You can actually use these geometry group directly to Geometry Gym, but sometimes it's hard to go back to your previous script and then bring it back to new script. So I would like to disassemble our actual Karamba model so that we can easily use those disassembled model component geometry to send it to Revit. So I'll just type disassemble model component in Karamba, which allows you to disassemble our calculated model to every components like model or points, beam, and shells, and etc. Now what we'll do, we'll extract the line, how many lines we have in entire model. As you can see, we have total 8 lines within this model that we can convert to Geometry Gym. Let's measure the length of curve, and I'll keep panel to see the information. And as you can see, these 4 lines, which is columns that has 3 meters of length, and the others are 5 meter and 10 meters of length in each. So I'll separate these lines by using dispatch, but before that, let's type larger than component so we can filter the patterns of dispatch component. I'll type 3 meter to see the information out of our pattern. It says all of them true. I'll make it 3.1 meter, which doesn't bother me. Then we have false for these column lines, and the others are true. So now I'll type dispatch component from our original list with these patterns. Then we'll get 2 different set of lines, 4 lines and 4 lines in each. Okay. Now, what we can start with this Geometry Gym. On the Geometry Gym, we can use Geometry Gym Revit bake file, which allows, if you double click later, we can bake our geometric definition to Revit IFC data. Okay, so you need to always have this component at the beginning, and we'll need to make a material. In before that, let's make a levels. For now, in this tutorial, I'll skip structural grid. I'm just gonna create levels. And to create levels in Revit, you need to have the name of levels and also elevation information. So I'll type just in panel. Let's say perhaps we make 2 levels, because at the moment we just need 2 levels. I'll type ground floor level, and I'll make it level 1 elevation, and I'll make it multi-line data. I'll untick the multi-line data, and let's provide this name as a level name in Revit. Okay, and I'll use series component. We'll start with 0, and we'll make 3 meter for the steps, and we'll make 2 levels instead of 10, and we'll connect this to elevation input. So we actually creating our level in Revit. So I'll make it create Revit levels by using Geometry Gym component. And now, once you define level in Grasshopper, and for the Revit, now we have to define actual material for each component. So I'm going to go ahead, let's go ahead, click on Revit material, which we'll create, and I'll provide this material for every single object, like floor or also for the beams. So name of material will make concrete in this case. So let's type concrete, sorry, concrete for the material name. Perhaps you can give C 20 by 25, which we define from Karamba to match with the calculation. So I'll give the name. And then our material setting is done. I'll set my mouse right button from class, and I'll pick concrete as a material in here. Okay, that's very important. So we created Revit material in this case. Create Revit material. Now I'm going to generate material for each, for wall layer or column layers or beam layers. So let's go next stage here. We have we have Revit material we create, and then we create material type for each layer. So in this case, we'll connect this material output to here, which is Revit material layer for specific case. And I'm going to give thickness of this material. We have 20 centimeter of concrete floor, so I'll use that. And we have function which is structural floor, which is correct, so I'll leave it function as a structural floor. And the wrap, I'll make it not true, so let's type boolean toggle. I'll make it false, so this is not going to, because it's core structure of floor, it's not going to wrap our finishes or etc. And it's structural component, which is true, so I'll leave it true. And variable, I'll leave it empty at the moment. So that's we generate material for floor object. Now we can apply our geometry to floor. So in order to do that, let's go next tab here, and I will use geometry floor type. We'll make type parameter for Revit. So what I'll do in here, I'll use again panel. In this case, I'll type concrete. Let's say C 20 by 25 floor as a type name of, again, C20/25 floor type. Okay, which is that, and I'm going to connect output as a name, and we'll provide this layer setting that we specify thickness and all the material setting in Revit to core of the floor. So this is core layer. See? So we have a little bit of steps. We have to create a generic mode material, and then we have to use this material to separate layer thickness. And once you've done, you have to create your type parameter for each element. In this case, we made floor type parameter. Okay, and there are a lot of other information you can provide. And for now, we use boolean toggle. Okay, this is interior floor, which is correct. I'll make it true, and I'll use other parameter as list. We don't need to provide other project parameter, so I'll ignore that. But I'll make this floor as a floor A as a type mark. Okay, we have floor A mark value as our Revit floor. And once you create this type parameter for floor, now it's time to apply actual floor type to the floor. So I'm going to connect my T value, which is type parameter, and I'm going to create our floor instance in this case. So we have some stuff that we can provide floor A as a mark value, and we need to provide actual slab parameter curve or bootstrap face. So what you can do in here, we have those lines that we separate from our geometry, and now I'm going to use boundary surface, for example, and let's say which line is which line, we'll find out. So this line is the one I want to make a boundary surface. Okay, so I'll use this surface model to create Revit floor. So we provide this boundary surface to create Revit floor. So floor is created. Now we'll create the columns and beams in GeometryGym. So let's go to Revit GeometryGym Revit component here, and this time we'll use Grasshopper GeometryGym Revit rectangle profile component. So we can define the depth and width of cross sections. Perhaps it's good to see maybe full name view to use GeometryGym. So I'll go on the view display. We'll make it display to full view, so we can just see the information better for each component. Okay, so a little bit this, yeah, we can ignore that. So now I'm going to create depth and width for our concrete beam, which will be 0.4 meter of depth, and then we'll make 0.3 centimeter, 30 centimeter, yeah, of the width for the beam. So that profile is here, we can apply, and I'm going to create our beam parameter component on the GeometryGym. And we'll create this beam, let's say concrete beam 40 by 30 centimeter, that we can give this name here. And now I'm going to connect our profile to this beam structural framing profile. Okay, and we have to provide now concrete material, which we'll use the same material from here. Then we create this type parameter for our structural framing. So we'll use pretty much the same material for all the components. And now we have type parameter for our structural framing. Then now we can define actual element for the Revit. That here, the usage will make it to girder or automated. At the moment, as default, it's automatic, but let's say it's going to be girder, that we can keep that information. And the framing type, we'll use the type parameter here that we'll connect in here. And the type mark, I'm going to give beam A as a type mark parameter. Okay, and you will use these axes, so that beam axis will be on the dispatch component. We distract these lines, so we'll connect this one to axis. Then we have beams on here, but they are actually need to go down a bit, isn't it? Because the floor is in the below beam location. So in order to do that, justification is as a mid, but I'll make it to top mid as a justification. Then our beam is located in the center, the top. Our beam location will be top face of our beam surface. Yeah, this is our location now. Okay, let's go ahead providing more information about the beam. So orientation we can ignore. Justification we set to top mid in this case, and material we have to give material from here. I'm going to give concrete material to here. Then we ready to send this beam component to Revit. Okay, so I'll leave it here as a beam component we create, and these are floor components. And now we'll create columns now. So we'll use the same component that we will create rectangular profile, and we'll give depth and width, in this case 30 centimeter, that's the same. And we'll give this profile for column type parameter. So we'll create column type which will use profile, same profile, and in this case, let's create name concrete column 30 by 30 as a type name we'll use. So we create Revit type parameter, and I'm also going to create a type parameter for mark column, say column A. In this case, we'll provide mark, and this is going to be structural column, so I'm going to use boolean toggle, make it true, and we'll provide that. And let's provide concrete material from here. So we have now type parameter for our column that we can apply to actual column instance. Okay, so we use connect this type to there, and we'll use same mark value from column A. We'll use it, and these axes we'll use from dispatched lines here, the second lines. Connect them down to the axis. Then we create 30 centimeters of columns that we can apply material from there to concrete Revit material. Yeah, then we finish creating columns as well. So as you can see, we create columns and beams and floor that we can send it to Revit.